Welcome to our session. We're looking at tutorial 4. And we're going to look at a number of measures of central tendency and dispersion. So in this regard, we're going to start with what we call the range. So the range ideally is the difference between the highest number and the smallest number. So range practically is used to estimate the values that will lie within a certain interval. So to find the range, it is simply the maximum value minus the minimum value of x. That's all. So in this instance where we're given values as follows, a 5-month period, we're given 485 as the smallest value, the highest value is 1075. So to find the range is simply subtracting the highest value, 1075 minus 485 to get 590. That is how we find the range. Okay. So we're also given a list of values for a 5-month period here, 485, 610, 775, etc. So from the data set, how are we able to find the range? So you can see here, just identify the highest value here. The highest value is 775, and the lowest value here is 485. So you can see the range is simply the difference between the highest value and the smallest value. Now, regardless of whether you're getting positive figures or negative figures, you need to understand that the range should always be a positive number. Now, the range can heavily be influenced by one extreme value in the data set that you may have. So you can see these are the same data sets, except that we've just adulterated 2 data sets. Where there is a 1075, we put 7075. So the extreme value in this case, 7075, is what has caused our range to increase from 590 to 6590. It's just a difference of values. Now, suppose we have negatives. Can we get a range? So here, we understand that the smallest value on the negatives, if you have only negatives, it's the highest value. But on the positive integers, the highest value is simply the highest numerical value. So in this case here, the smallest value is what? The largest negative numerical value. So negative 10. Then the highest value here is 32. So the highest value minus the smallest value. So 32 minus negative 10. So this negative and the negative will give us a positive. So 32 plus 10 will give us 42. So this is how we find our range. So in the case that all of them are negatives, so like I said, the smallest value in the negatives is the highest value. So here the highest value is negative 2. The smallest value is the biggest numerical value here, which is negative what? 25. So we have 2 negative 25, so you can pick any of them. So the highest value negative 2 minus negative 25. So we know that this negative and that negative will give us a positive. So 25 minus 2, which is 23. Are we following? Are we together? So this is how these tutorial questions are supposed to be answered. So here, it is this value minus that value. Here, we pick the highest value, which is 16, 32, and the lowest value, which is negative 10. Here, they are all negatives, so we have negative 2 and negative 25, okay, 23. All right. Any questions so far? Are we moving together?
Yes, we are.
All right, so now we also go to a scenario where you're given values to identify the quartiles. Now, quartiles are simply values that will have positions. So in this case here, we have a number of values starting from 75, 86, 87, ascending up to 120. So these values need to find positions. So we have 75 up to 120. So the first quarter you need to understand is what? A quarter. Quarter 1 is what? A quarter of n. Quarter 2 is 2/4 of n, which is same as half. Quarter 3 is 3/4 of what? N. Now in this case, n is a number of observations. So in this case, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Our n is 10. So whenever you find the position and the value that you get is a decimal, you always round up. So a quarter of 10, this our n is 10, is 2.5. So 2.5, the position you round up, which is approximately the third position. Whether you have 2.1, 2.2, 2.5, as long as the decimal point, so here we get the third position. So we're going to manually count 1, 2, 3. So the third position in here is what? 87. So this is what our first quarter is. Then we go to half. Our second quarter, so this is Q1. Our Q2 is half of what? N. So half of 10 is 5. Now, whenever we have a single discrete value, the rule is we add the next position. Okay? So 6th and the 5th position, then you divide by 2. So in this case, we're going to have 1, 2, 3, 4, 5, and 6th position. So 94 and 102. So when you count them manually, 94 and 102 divided by 2, you're going to get 98 as our second quarter. So 98 is second quarter. Okay. Then third quarter is 3/4 of n. So 3/4 of 10, we're going to get 7.5. Remember, if you have a decimal point, you always round up. So this is the 8th position. So if you're going to count the 8th position, 1, 2, 3, 4, 5, 6, 7, 8. So 109, in this case, will be our 8th position. So that is our third quarter. So this is how we find the first, second, and the third quarter. Are you together?
Yes, Collins. I have a question.
Uh-huh.
You mentioned that even if it is 7.4, 7.1,
Yes.
you have to round up to 8.
Yes, you round up. You always round up whenever there's a decimal. Yes. Whether it's 7.1, 7.2, that's a rule.
Okay.
So precisely, if you've noticed, I'm following what your lecturer is using. So let's be precise to the latter. Okay. Then when we want to find the interquartile range, you now find the quartile number 3 minus quartile number 1. So we had 109 for third quartile and 10.87. So the difference between the highest quartile and the lowest quartile, that is what we call the interquartile range. So the interquartile range is the difference between this and the third. That's what we call the interquartile range. Okay. Any questions so far? Anyone behind? So we need to.
So interquartile range has nothing to do with position, not so.
No, it is just a range of the quartiles.
Okay.
The highest quartile. But half of the interquartile range is what we call the semi-quartile deviation. So what did we say? To find the first quartile, it is simply a quarter of what? N. To find the second quartile, it is simply half of what? N. To find the third quartile, we found what? 3/4 of what? N. All together. Then the answers that we're going to get, for instance, if we are going to get 1.5 7. The nearest is what? The second. When you get 1.2, the nearest is what? The second value, regardless of what figure you get. Okay? You round up. So here, whatever you get, so the answer that we're getting, the figures are x. If you here, we're going to get 2.5. You're rounding up the position is the third position. The value that you're going to get is y. Then here, if you get maybe 3.9, the round off the nearest value is the fourth position. Maybe this is z. So the difference between quarter 1, quarter 3 minus quarter 1, that is what we call what? Interquartile range. Okay. So I hope that's clear so far. Before we proceed to anything, any questions, please ask. Any questions, please ask. All right, so we got to another question. So we're looking at question number 5. A cereal producer uses a filling process designed to add 16 ounces of cereals in each box in order to meet the quality control standards. And the quarter range must be less than 0.4 ounces, centered around the target weight of 16 ounces. So the table shows the list of weights of 24 cereal boxes in the quarter range to determine whether the sample meets the quality control standard. So we're given the following values in here. So this is a question here. So we've been given the following weights of 24 cereal boxes. So questions that we've been asked. What is the question? Calculate the interquartile range to determine whether this sample meets the quality control measures. Okay, so we need to calculate the interquartile range. So if we're given a data set like this one, so remember, fortunately, this data set is arranged in ascending order. How many are these ones? They are in total 20 what? 4. So n is 24. So we need to find the first quarter. Who remembers how to find the first quarter? A quarter of what? N. So a quarter of 24 is what? The 60th position. So what do we do if you find a whole number? You get that position and the next number. 60th plus what? 7th, you divide by 2. So we have 1, 2, 3, 4, 5, 6, and 7. So these two, we add them. 15.76 and 15.78 divided by 2. So 15.76 and 78 divided by 2. So this is our first quarter. Are we together?
Yeah.
Quarter number 2 is half of what? N. So half of 24 is the 12th position. So 12th position plus the 13th position divided by what? 2. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 16.02 and 16.05. So we go here. This was Q1. Okay, Q2. We don't need the Q2 in short, because the interquartile range is simply Q3 minus what? Q1. So that's why it wasn't found here. So however, the Q3 is 3/4 of what? N. Q3 is 3/4 of what? N. Our N is what? 24. So 3/4, that is 6 times 3 is 18. So it's the 18th and the 19th. So 12, 13, 14, 15, 16, 17, 18, 19. So we're getting 16.22 and 16.30. Okay, 16.22 and 16.30. Divide by 2, we're going to get this figure there. So the interquartile range is the difference between 16.26 and 15.77. So when you get the difference, it's got the interquartile range. Now, the question is, does it meet the quality standards? Because we are told that the standard deviation, the preferred error must not be what? Must be less than 0.40. The deviation must not exceed 0.4. So here our deviation is 0.49. So it's slightly above our tolerance level. So it doesn't meet the quality standards because it is what? It is more than the standard, which is 0.40. Are we together?
Yeah.
Yes, we are.
Is this making sense? Okay. So we now go to question number 6. The table shows a list of 15 houses in a particular area where they're being weighted, awaiting sale. So using the quarter range, determine if this data set contains outliers. So fortunately, this data here also has what? It has it's in ascending order. Okay. So now we're going to find the box whisker plot. So let's identify the quartiles. Remember, how do we find the quartiles? Which figures we have here? How do we find the quartiles? So to find the outliers, you need to identify 5 key elements. Number 1, the lowest value of x, which is x mean, and the highest value of x, which is x max. Then the quartiles Q1, Q2, and Q3. Can somebody help me? How do we find Q1? How do we find Q1?
That's first quarter of N or
Quarter of N.
observations.
Okay. So Q1 is what? A quarter of N. So from our table, given 15 houses, so our N is what? 15. The lowest value is 9 and the highest value is 115. So at least we have 2 values of the box whisker plot. So we have 9, we have 115. So we need to find the first quartile. So Q1 is what? A quarter of what? N. And our N is 15. So a quarter of 15 is 3.75. And we always round up. So this is the 4th position. So we count 1, 2, 3, 4. So 36 is our Q1. We'll put 36 here. So Q2 is half of N. So this is where 36 is coming from. So Q2 is half of N. What is half of 15? 7.5. 7.5, and here is the 8th position. So what is the 8th position? 1, 2, 3, 4, 5, 6, 7, 8. So we have 50 there, which we put here. Then we also find Q3. How do you find Q3? 3/4 of N, right? So what is 3/4 of N is 11.25. Remember, round up even if it's smaller. So this is the 12th position. So 12th position, you find as 64. So you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's where 64 is coming from. So we put 64 here. So can somebody tell me what is the difference between these two codes? 64 minus 36 is called the interquartile range. So what are we getting? Interquartile range?
28.
8, right? This is 28. Then the correction term is simply when you apply the interquartile range times 1.5. So the standard figure, multiply the answer by 1.5. It's called the interquartile correction term. So
42.
8 times 1.5, we get a 42. So this 42, you add it to this 64. Then here you subtract it from this 36. So the 42, we subtract it here. So let's add 64 plus 42. What do we get?
106. 106.
106, correct? So 106 is somewhere here. Then you subtract 36 minus 42. What do we get?
-6.
-6. So this 9 has survived because it's inside. This 15 has not survived because it's outside, because we are cutting this part outside there. So this 115 becomes an outlier. So to redraw our box whisker plot, before I redraw it here, so the lower limit is -6, the upper limit is 106. So what figure is outside that range? If we're going to check in here, only 115. So in this case, we're going to say any data set that is outside the limit of what? -6, 106 is called an outlier. In this case, our outlier will be 115 because it's greater than the upper limit. So we can consider it to be an outlier. Are we together?
Yes, we are. So, Collins, a simple definition of an outlier.
It's an odd one out.
Just when
An odd one out in layman's language is you are 7 children, you have 1 girl, she's an outlier. So an outlier is simply the principle is in this context, we're going to use a ruler. So this ruler must range between what? -6 and what? 106. So if you're going to place it in here, -6 engulfs this figure there. The ruler will go up to past 94, but it will not exceed 115. So 115 na ipulamo, outlier. Pulamo means you're an outlier. All right. Are you getting my example?
yeah. Okay.
All right. So that is how this question was supposed to be answered. Question number 6. All right. So all these questions are there in my the QM Bible. So I just need you to understand them because questions from the exams will come from there. So if there are no questions, we can proceed to another example here. The following table shows 18 randomly selected airline flights. Okay, these ones were either early negative values or late positive values arriving at their destinations. So use the index to calculate the interquartile range and determine which ones are the outliers. So same, this one is the smallest number, and this one is the highest number. So to start with, an outlier has to be the odd one out. So how many figures are they? They're 18. So although you're not being asked to draw here, I just want you to illustrate it for benefits of you understanding the concepts. negative 42, and here we have 64. Okay, so quarter 1 is a quarter of what? 18. So a quarter of 18 is giving us 4.5 to the nearest, the 5th position. 1, 2, 3, 4, 5. So we have negative 4 here. Then quarter number 3 is 3/4 of n, and 3/4 of n is giving you, what is 3/4? Is going to give you times 3. This times 3 is what? 13.5. The nearest, which is 14, or 13.5, and the nearest, which is 14. 14th position, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 20 is our what? Or Q3. Now, the difference between the highest value and the lowest value. Now, you need to be very careful with indexers. It's 20 minus negative 4, which is what? Positive what? 24. Then multiply this 24 times 1.5, which is a correction term. Multiply by 1.5. What do you get? 24 times 1.5?
36.
36. So add 36 to the 20 and subtract 36. Okay. 4 minus 36. What do we get? Negative 40. Somewhere there. Then 20 plus 36 is what? 56.
56.
So which ones are out of the ruler? Okay, 40 to 46 from here. Which figures are outside this ruler? Negative 40 and 56. Which ones are out?
61 and 64.
Sure. Only?
Which one are out?
Yes, outside.
Okay, okay. Okay, it's 42, negative 42 is outside, 61 and 64.
So you're going to have 3 outliers. Okay. So we can see that negative 42 is below the extreme lower value, and on the upper values of 61 and 64. So these are our 3 values. So it's not always that it's going to be 1. All right. So this is how this question was supposed to be answered. This is how this question was supposed to be answered. So these are the outliers. I hope you are following. Am I too fast for somebody? Macy, are you there?
I'm here, fine.
All right. Mr. Juma,
I'm following.
all right. So let's go to this question here. Would you want to try? We're given an 11-day period. We're asked to construct a box whisker plot. So what do we do? And also determine the shape using the box whisker plot.
We identify the x minimum and the x maximum. The x minimum, which is 20, the x maximum is 92, because they are in ascending order.
Excellent. All right. So we have the x minimum, 20, x maximum, 92. Now do you find the Q1 and the Q3?
The Q1 quarter of 11, and the Q3 3/4 of 11, which is n.
So calculate for me what is a quarter of 11.
2.75,
So we have
which is
X mean and X max. What does our X mean?
20.
I mean my value 20, then 92, right? 20 here and 92. How do you find the Q1?
The Q1 is a third. The Q1 was 2.75, which is the third position
So
in the range.
2.75,
75.
which is the third position. And what is our third position according to this data? 1, 2, 3. So what is this? 29?
29, yeah.
Then to find our Q3, 3/4 of 11. What is that?
8.25,
Hold on.
which is the ninth. 8.25, which is the ninth position.
Good. Ninth position. 1, 2, 3, 4, 5, 6, 7, 8, 9. Is what? 70. And what is our second quarter? Half of 11, which is what? 5.5 to the nearest.
Well,
The sixth.
Sixth position.
What is the sixth position here? 1, 2, 3, 4, 5, 6. Which is what? 56, right? Okay. Then how do you find the interquartile? What is our interquartile range?
It is 70 minus 29.
70 minus 29.
That's 41.
That is 41. Okay. Are we together or are we following?
Yes, we are cool.
Okay. Because there's only one person participating well. So I need us to be together. Okay. So our interquartile range is what?
41.
1. Our correction term is what? Multiply by 1.5. What do we get?
61.5.
1.5. What do you do? The 61.5? You add it here and you subtract it from here. So what are you getting on the upper limit?
131.5.
131.5. But on the lower limit, let's show it's 131, 121 or 131. Oh,
131.
131, okay. Then here, 29 minus 61. What do we get?
Negative 32.5.
Negative 2.5. What is our outlier? Do we have any outliers?
It's got
No.
the number of observations on the line. No, we don't have.
Good. So it's not always
We
that
don't have all of them. All of them, they're inside.
inside. So we found 41 here. Okay. Then 131.5 and here. So meaning when you calculate these ones, you see that they sandwich. So we had what? You are also advised to do a number line down there to just illustrate. Now, the 20 is the lowest number and the highest number was 92. The first quarter we found what? 20, 70, and 56. All right, which we have illustrated here. This is what? 29, 56, and 70. All right. Now, after establishing that, we added here, we got 130, 1 point what? Found 130.
131.5.
Then negative 2.5. So 131.5, which is here. Okay, negative 32.5, which is there. So here there are no outliers because everything is within. Now, describe and sketch the skewness. So in this case here, can we say it's skewed to the left or it's skewed to the right? So
Skew to the right.
it's skewed to the right. How do you know?
I remember. And the box and whisker plot would tell us where if we divide the box itself and where we have I think by observation of the interquartile interquartile range.
So we've established there's no
Quartile.
So you look at where the box is bigger. It's larger here, it's smaller there. So if it's larger on the left, it is skewed to the left. If it's larger on the right, it's skewed to the right. So this one is skewed to the left.
Oh, okay. Yeah, I think I remember now.
Although for him, he uses a person where you're going to look at this. This is what? Skewed to the right, because you face here, you draw a person who's looking this side. All right. So it's facing this side. So when you face the side and the distribution looks like that, this means skewed to the what? To the right. It's opposite. When you go here, it's normally distributed. When you go here, the person facing, if you're using the distribution, this one is skewed to the, when it comes side, it's skewed to the what? The left. It's like the opposite. But it's easier to use a box to look at the differences in the gaps. So this gap is big, so it's skewed to the left. All together. So describe the shape of the distribution. All right. So we're going to end here.